Alright, so we're graphing logarithmic functions, and we're going to go ahead and start off by graphing 2 to the x, which I went ahead and copied the table from the last section, and we're going to go ahead and graph it now. So we have negative 2, 0.5, 0.25, and then negative 1.5, 0, 1, 1, 2, and 2, 4. So here is 2 to the x. Now, this is a one-to-one function because it passes the vertical line test and the horizontal line test, which means it has an inverse. The inverse, what you would do is you would take these points and switch the x and the y. So 0.25, negative 2, 0.5, negative 1, 1, 0, 2, 1, and 4, 2. And we're going to go ahead and graph that now. So that is 0.25, negative 2, 0.5, negative 1, 1, 0, 2, 1, and 4, 2. And that is the inverse, and what we call that inverse is log 2 to the x. So that's where the logarithmic function comes from. It is the inverse of the exponential function. So it was there to undo the exponent. So the definition of a logarithmic is if y equals log b to the x, that means x is equal to b to the y. So we're going to go ahead and switch between logarithmic functions and exponential functions. So this is log form, and this is exponential form. Okay, so example number 2, we're going to rewrite all these log forms as exponential form. And one thing that we could do is we could snail it. So I'll teach you how to snail it. So you start at the base, so your base is always going to be that subscript right there. So it's 5 to the 2 equals 25. So 5 squared equals 25. You could do the same thing over here, and you're just going to leave it like that. 5 squared equals 25. Then over here, start at the base. So 6 to the negative 1 equals 1 6. 2 to the 1/2 equals square root of 2. Alright, so these would be exponential form. Alright, next we have logarithmic form. So this one we can't undo the snail or anything like that. What we're going to do is we're going to start off with our log, and your base is always going to be your subscript. So that goes there, which is 9. And then the 729 goes next, and it's always, your log is always going to be equal to your exponent. Alright, we'll do the next one. So log of your base, which is 6, and then what's on the other side of the equal sign, equal to the exponent. That would be log form. So if we go back to this, I can color code this so you guys could see where everything is rearranged. So y equals and log to the b, and then we could say x. So you could kind of see where everything went. Alright, so next we have find the value of each of the logs. So what we're going to do is we're going to set this equal to an x or any variable that you want, and then we're going to go ahead and snail it. So 4 to the x is equal to 16. And then you learn how to solve these in the previous section, so we could rewrite this as 2 to the 2x is equal to 2 to the 4. And so set the exponents equal to each other. 2x equals 4. Divide by 2. X equals 2. And that would be our answer. Alright, the next one, we We're going to set it equal to x again, and here we don't have a base, so if we don't have a base, it's base 10. So 10 to the x is equal to 1/10. 10 to the x is equal to 1/10. Well, if you remember from exponent rules, if you have a base to a negative number, you could rewrite it as 1 over a to the n. So basically, we could rewrite that 1/10 as 10 to the negative 1, and x is equal to negative 1. All right, we're going to continue to snail stuff to solve. So now we're going to be solving for logarithmic functions. So 4 to the x is equal to 1/4. 4 to the x is equal to 1/4. Well, we could do the same thing. So 1 over 4, we could rewrite that as 4 to the negative 1. Now we have the same basis, so x is equal to negative 1, and that would be our answer. All right, the next one, 5 to the third is equal to x. So therefore, x is equal to 125. And the last one, x squared is equal to 25. So this one, you probably want to think about it logically. What do I have to square to get 25? 5, right? So x is equal to 5. You could also do -5, but if you read the directions for the logarithmic, your bases have to be greater than 0. So you could only have 5. All right, so this would be our answer. And we have 2 more. So we're going to snail this. So 3 to the x is equal to 1. So what does x have to be in order for this to be 1? So anything raised to the 0 power is 1. So x is equal to 0. And then the last one, b to the x is equal to 1. So same thing, if I raise b to the 0 power, that's going to give me 1. So x is equal to 0. And this is just saying that b could basically be any base. So now if I have something like log 100 to the 1, that is going to be 0. So log b to the 1 will always be 0.